Hello and welcome to another JPS tutorial video. I'm Josh DeWitt, a student supervisor for the Jacobs Institute, and today we're talking about laser cutter file prep in Illustrator. The laser cutter is one of the most used tools in Jacobs Hall because it allows rapid creation of 2D parts. From an outline to the finished part, a laser cutter can create parts faster than a 3D printer and with more solid materials. The first question is always, can or should I cut this on a laser? If you've got a part that is a bunch of flat shapes folded together, the laser cutter is ideal. If you need a box, laser cutters are going to be much faster than 3D printers, and you can get clear boxes or fully enclosed shapes more easily. There's a lot of complex 3D geometry. A laser might not be the tool for the job. Lasers are also really good at making text appear on your project or labeling control panels. If you aren't sure, be sure to consult a design specialist. Now that you want to send in a laser cutter file, how do we do that? The first thing is to design the part, which can be done either directly in Adobe Illustrator or in a 3D CAD program like Autodesk Fusion 360 or SolidWorks. If you head to software.berkeley.edu, you can get access to both Illustrator and Fusion for free as a member of the Berkeley community. Let's boot up Illustrator and get started. The first thing we want to do is create a new file. Even if I'm opening up an existing image or drawing, I always like to start from scratch, as that gives us a little bit more control over the settings. First thing is to come up with a name for our file, so we'll go with Cool Design. There are three key settings: the artboard size, the color mode, and the units. I start from the web presets because that automatically changes the color mode, which is the most important change, but we'll go over all three now. In terms of selecting our units, I like to use inches or millimeters, depending on what my part's native unit is. So we'll go with inches here. Physically, we have three 18 by 32 machines and one 24 by 48 machine in the Makerspace. In general, most of the material in Jacobs Hall is 18 inches by 30 inches, so we'll use that for our artboard size. If you need to go larger, you can go to the larger size, 24 by 48, but it might be better just to use multiple artboards and therefore pieces of stock. Note that the lasers are really wider than they are tall, so we want to enter 30 inches, then 18 inches in height. The last thing we need to do is set our color mode. This needs to be in RGB so that the laser can understand the different line types we are feeding into it. CMYK is what paper printers use, but most computer graphics are done in RGB. The easiest way to get most of these settings is just to make a preset that we can come back to. Once you create one file like this, it will be saved to a recent tab for presets. Inside the Illustrator environment, there's a lot going on. First things first, we can change those three settings we just did or confirm they are correct. Go to File, Document Color Mode to toggle CMYK and RGB. To change the size of our canvas, we can go over to Artboards and into Edit Artboards. Here we can change the size of our artboards, the basic canvas in Illustrator. If we want to make more artboards, this is also the place to do that. We can click on the little plus button and create more artboards, give them names, or apply a different preset. Not recommended at this point. Lastly, if we want to change units, we can exit artboards and change our unit. Here we can also select which artboard is active. From here on out, we'll use a single artboard for simplicity. Before we get too far, here's a little foray into navigating around the art space. On a traditional mouse, scrolling up and down moves you up and down, but scrolling while holding Control or Command on a Mac lets you move left and right. Scrolling with Alt will zoom in and out, and holding Shift will move left and right faster. Great, now that the file is set up, let's get some cool parts in here. There are several ways to import parts. If you design in Fusion 360, AutoCAD, or SolidWorks, export the 2D face as a DXF, then we can load it into Illustrator with the Place command. It's under File, Place, or Command-Shift-P on Mac, or Control-Shift-P on Windows. We can then navigate to the file we want and select multiple, then click Place. We can then place the file where we want it, and then get pulled into the primary editing interface. On the right side, most of the tools we need are visible. The first thing to check is the size of the part. The transform section will show you the size, and it's worthwhile to make sure this matches what you expect from your CAD model. If you click the little chain link, you can lock the aspect ratio, which is the easiest way to resize the part to fit the correct dimensions. Here, you can also specify an exact location of the part, which can be useful, but clicking and dragging is also pretty easy to use. There are three types of actions the laser cutter can take. Rastering draws images onto the material like a paper printer, increasing or decreasing the depth of the cut depending on the darkness of the file. Scoring follows the path of the file, but does not cut all the way through. Cutting follows the path of the file, but will cut through and separate the material. These last two each have a specific color. Scoring uses blue, cutting uses red. These two vectorized cuts need to have a hairline or a 0.001 thickness line. Anything not in these two colors or thicker than around 0.072 points will be rastered on. So any filled shapes will automatically be rastered regardless of color. The color will only set the approximate depth of the raster on a gray scale. Swinging back to our Illustrator file, we want this imported DXF to be cut. Looking at the Appearance tab, we see the fill and stroke settings. Stroke is the outline, so I'll set the stroke color to red. There are presets within our color mode, but it's important to double check this. We can move to the color palette and make sure it is all red, no green, and no blue. This ensures that the laser will actually understand the part we want to cut. We then want to change the line width to 0.001. That should get that part all set up, so you can click elsewhere on the artboard to deselect it. You should notice that it goes almost transparent, or at least hard to see for the most part. This is because the thin line type doesn't always render multiple pixels wide. There are a few ways around this. One way is to do the alignment and set up with a thicker line width, or use outline mode, Control-Command-Y. This converts all the vectors to a visible black line, which can be very helpful. Now, let's add an image. The raster setting of the laser allows us to embed text, images, or other markings really easily. Little coasters with personalized images or messages make a great gift for special occasions. As a side note, it is important to note cast versus extruded acrylic for rastering. Jacobs primarily uses cast, which is good for rastering since it creates a frosted surface, but extruded acrylic, more rare in the Makerspace, gives cleaner cut edges. Also, since acrylic is clear, rasters on it appear white, so it might be worthwhile to invert the color scheme of any photos. Wood doesn't have any issues and will raster on dark. In terms of choosing images, JPEGs are preferred. PNGs have been known to cause some issues, which we can talk about in a moment. We can import our image through Place the same way we did with DXS. File, Place, and choose our file. Once we click it into place, we should see the image as it was, but with some blue lines crossed over it. This signifies that it is a linked image, which is a problem when sending files to JPS. Illustrator has a symbolic link to the image elsewhere on your computer, which is good for storage space, but not for portability. The best way to fix this is to go to the bottom right and click Embed. This then copies the image into your file and makes it ready to send on its own. To resize our image, we can use the transform tools on the right sidebar or click and drag it. This tool also works for any object, but images tend to be less critically dimensioned. We can click and drag in the middle of the image to relocate it or move to the corners to resize it. Just dragging a corner is a free resize, and moving slightly off to the center is a rotate. If we hold Shift, we maintain the aspect ratio, like the chain and transform, and move the corner we selected. If rotating with Shift, it only rotates in 45-degree increments. If we hold Alt, we can resize about the center of the image. Alt has no effect on rotation. For resizing, we can also combine Shift and Alt, and the image moves like a bullseye, growing and shrinking about the center point. This is a quick aside as we get into more and more Illustrator tools. Unlike a lot of CAD software, hitting Escape does not exit out of the current Illustrator tool. The basic tool we've been using up until now is called Selection and is accessed with the shortcut V. If things aren't working, hitting Escape a few times and then V should reset your cursor back to selecting things. Since the raster goes across the image and fires the laser according to the pixel darkness at each location, it's important to have the image in that same format. PNGs tend to not work as well, so a fix is to go to Object, Rasterize. This will convert any vectors into just pixels. It's definitely worth getting the image to size before rastering, as the resolution you select will be based on the image's current size in your artboard. You can also change around with the settings, but I prefer the 300 dpi and transparent background. The laser cutters work at either 300 or 600 dpi, dots per inch, so this resolution works well, and the difference is almost imperceptible, especially on a laser rastered part. Another tool we can use is image tracing. This also helps with PNGs and other files being weird, but it creates a distinct look. Usually, image files are stored as a bunch of colors and locations, plus or minus a bunch of fancy math for compression. But with an image trace, we can convert the pixels into vectors. This is really good when you need to upscale an image by a lot and can sometimes help remove weird lines across vector rastered images. This tends to work best with cartoon images or other things with well-defined outlines. High fidelity photo is often pretty good, but you can see the differences when you zoom in. This is most useful to extract shapes from an image, in my opinion. I created a water bottle sticker by image tracing the Calvans logo and then vinyl cutting the image out, so it can act as a way to recover vector imagery if you want to cut out a specific shape from an image. Also be aware it can take much longer to resize a vector traced image since there's a bunch of math going on when it changes size. The last thing to touch on images is masking. There are ways to crop images in Illustrator, but we can also do shape cropping. This is useful if you want an image on a non-rectangular part. Any image not on the final piece is just wasteful of both time and material. So what we want to do is select the shape, let's do a star here, and place it over the image, selecting which section we want. Here, it's definitely worth it to have the line width be thick enough to see over the image. Ensure that the vector shape is over the image and both are selected. When we have what we want, we can go to Object, Clipping Mask, Make. This will combine the two so we can only see the part of the image that was inside the shape. We can then edit the stroke if we want this part to be cut out, and we have trimmed the image to just fill what we need. If we take a peek in outline mode, we can see two limitations of this view. First, all images are just converted to rectangular outlines, so we can't see any of the image data within. Also, the image outline is still visible even when we have masked the image with another shape. The final line type is scoring, which we'll cover with some text. To score or not to score, that is the question. Whether it is better to score text for speed or raster for higher visibility. I tend to prefer to raster it since it makes it easier to see from a distance. But there's some quirks of text for JPS that we need to cover either way. We can add some text with the text tool, annotating a part quite easily. If you're done typing, we can hit Escape to return to the general editing view. We can select the font or make it larger over in the Character tab. If you select the text box, the entire set of text will change, but if you're in the typing window, you need to select the text for it to change. If you want a specific font for your design, you should select it now. The interesting thing about fonts is that they are stored system-wide, not within the file itself. So if you send this file to JPS and the computer doesn't have that font, it'll revert to something plain and boring. It's therefore quite important to do this next step, akin to embedding an image. Once you're happy with the content, font, and appropriate size of your text, we can convert it to outline. A side note on outline mode, text will appear as filled in when seen as characters. Create outlines is in the bottom right corner and will change our text from characters to a bunch of vectors. When selecting it, the style should change. Now in outline mode, the text will appear as a stroke with no fill. We can't edit the text, but it is much more portable and won't be corrupted when changing computers. If we want to score the text, we can set the stroke to blue, 0.001. If we want to raster it, we can just fill it in with whatever color, often black for visibility. You can now treat the text like any other object, resizing it or rotating it. These actions can also be done before it is converted to outline, so there isn't really a mandated order. If you have multiple parts, it's important to nest them or make them take up as little space as possible. The kerf or material lost when the laser cuts is very thin, on the order of 75 thousandths of an inch. This is very small, and so parts can basically sit on top of each other, which reduces material waste and keeps your JPS bill down. With nesting, you want to try to fit all the parts together in a small approximate rectangle, moving them close together to minimize waste material. When doing batch work, where you need several of the same part in the same order, you can specify how many you need in the README, but everyone will have an easier time if you lay out all of the parts ahead of time. This will also help you get a better sense of how much material will be needed to complete your order and what the approximate cost will be. Now we are pretty much ready to save our file and send it to JPS. If you have multiple parts or thicknesses, it is important to specify that in the README and create a consistent and easy to understand naming system that clearly communicates exactly how you want your parts to come out. One way I suggest doing this is to label each Illustrator file or artboard with a description that matches the README, as well as the desired material and thickness. So we might rename our file to something like Cool Wrench acrylic18.ai, which would be very easy to understand. The README should be a basic text file, so Notepad on PC or TextEdit on Mac work great for this. For demonstration purposes, I also created another file to show the naming system, other file, plywood1/4.ai. The more explicit you are about everything in the README, the easier it will be for your parts to be made correctly. While not necessary, if you have a CAD model or a very complicated part, it might be worthwhile to include an image of what the part is supposed to look like in the zip file in case a line doesn't get registered as a cut or something similar. Once you have all your files labeled and a README written with any special instructions, it's time to zip everything together and submit it to JPS. And that should be it. Now you're prepared to submit your file for Jacobs project support. Thanks for watching. Check out jacobsinstitute.berkeley.edu and our YouTube channel for more tutorials, workshops, and maker-related content. Stay safe and make stuff.